So we're going to take multiplying and dividing of variable terms to the next level. It's called multiplying and dividing powers in 10.8. So 2 squared, right, is 2 times 2, which is 4. 2 cubed is 2 times 2 times 2 is 8. Now the next one is 2 squared times 2 cubed, right? So 2 squared we just said was 4. 2 cubed is 8, so 4 times 8 is 32. Now what's 2 to the 5th power? It's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. These two have the same answer. Now we just said 2 to the 5th was 32, and what's 32 times 2? Oh, that's 64. Now what do we think 2 to the 6th is? Well, it's 2 times 2 times 2 times 2 times 2 times 2. Now we just said it was 32 times another 2. It's also 64. So why is Mr. Ben having me multiply by 2? Well, let's see. 2 squared times 2 cubed had the same answer as 2 to the 5th. That's interesting. 2 to the 5th, that was this right here. They had the same answer, 32. 2 to the 5th times, I'm going to put the exponent in, 2 to the 1st, right? That's what 2 is, equal 2 to the 6th. Are we seeing a pattern there at all? Let's see if I can make it more clear for you. So here we go. X times x is x squared. We already learned that, but I'm going to make it a little clearer here, right? That's x to the 1st times x to the 1st, right? X times x is x to the 1st times x to the 1st, which is x to the 2nd, or x squared. Interesting. X cubed times x to the 4th is always x to the 7th. No matter what number x is, they're always equal. For the y's here, I'm going to put the 1's in, right? We learned that y times y times y is y cubed. But y to the 1st times y to the 1st times y to the 1st is y to the 3rd power. And y squared times y to the 5th always will equal y to the 7th. So is there a pattern? Is there a shortcut? Yeah, there is. Right? You can add the exponents. This is multiplying. We'll go over dividing in a second. But multiplying powers, you literally just can add these exponents. And there's lots of uses for that. So y to the 1st, right? You add the 1 plus 1 plus 1 and get 3. Here you add the 2 plus 5, you got 7. And that was what was going on in the warm-up as well. All right, so to multiply powers with the same base, the base, the x, the bottom, has to be the same. But x squared times x cubed is always going to equal x to the 5th. Okay? Now, don't start doing 7 times 7 is 49. Treat that 7 just like you treated the x. So this would be 7 to the 8th times 7 to the 1st. It's going to equal 7 to the 9th. Notice I underlined the word simplify. If I say evaluate this, and you better hope I don't, because you would have to do 7 times 7 is 49 times 7 times 7. No, you don't want to do that. More often what we do is we simplify things like that. So when you multiply powers, right? This is 7 to the 8th power times 7 to the 1st power. When you multiply powers, the shortcut is add the exponents. So you're not going to start multiplying 10 times 10 times 10. You treat this just like if it was x squared times x cubed times x to the 4th. And so this is 10 squared times 10 cubed times 10 to the 4th. You add 2 plus 3 plus 4, and you get 10 to the 9th. If you had it with x, you would write x to the 9th. 1/3 to the 5th times 1/3. This is 1/3 to the 1st, right? Remember, when you have a base that's a fraction or a negative, you need the parentheses. This is 1/3 to the 6th. Now we have a coefficient. That 7 is a coefficient. You're going to bring that along to the answer, and then you're going to add the exponents. This equals 7 times x to the 8th. You bring the 7, right? Because we've done this before. We've done like 7x times x, and that was 7x squared. Now you're learning a more general rule, right? X times x was, you added the exponents, and you kept the 7. So that's 1y times negative 3y to the 11th. So you bring the negative 3, y times y to the 11th is y to the 12th. This is negative 3 times y to the 12th. But you just say it as negative 3y to the 12th. Now you can only multiply things with the same base. So the x's get multiplied. X squared times x to the 5th is x to the 7th. Y cubed times y to the 6th is y to the 9th. For any, you can go play with the calculator. Any number you put in here, right? Wouldn't you rather do the one on the right? It's much simpler. Okay, whoa. All right, now two negatives make a positive, right? So that's going to make this easier, right? This is -1 times -1, which is +1. So don't let that throw you. Now, you might want to put the ones above the x's. X times x is x squared. We've done that part. I'm going to cross those out. Y squared times y is y cubed. Z, right, that's z to the first times z cubed is z to the fourth. And how you would say that is x squared y cubed z to the fourth. You don't need to say the word power. And that is much simpler than what we started with. Two negatives multiply to make a positive, still. All right, so that was multiplying. This is dividing. Now, really, instead of dividing, you're going to just cancel things. So look at this. If you have x cubed, right, that's x times x times x. X squared is x, right? Well, you learned you can cancel things that are the same top and bottom. So that's just x on the top, also known as x, right? There's a 1 here, but x over 1 is x. Here, the extra x is on the bottom, so that's not x. That's 1 over x, the reciprocal, right? So let's write this, right? So you can cross out all those x's. So you crossed out 2 there. So after you cross out those 2, how many are left up there? 3. So this is x cubed over 1, which is x cubed. Now let me just write that out just to show you, right? It was x to the 5th on the top, x squared on the bottom. Those cancel. There's your x cubed. This is division, right? Right? We've learned that that bar means division. But we'll talk about that. So we're going to not doing any 2 times 2 times 2, right? We're canceling the 2 cubed. And 8 minus 3 is 5. So this is 2 to the 5th. And make sure where that 5 goes over 1, which is 2 to the 5th. So what's going on here, right? When you're multiplying powers, you add the exponents. What did we do here? We subtracted the exponents. But there's a little trick to it. Why didn't I just write that up in the notes? This is why. So there's one y on the top. And then how many y's on the bottom? 2. So this is not y squared. The y squared's down here. What goes up there? 1, right? When everything's gone in a fraction, you get 1. So this isn't y squared. It's 1 over y squared. So that's why I didn't write subtraction up there. Yeah, 3 minus 1 is 2, but it's down there. We're canceling. You have to make sure you know where the extra x's and y's are. Are the extra x's in the numerator or are they in the denominator? So again, you treat that like x or y. So the 9 times 9, the 9 squared goes away. 5 minus 2 is 3. And this is 1 over 9 cubed. That's all you have to do. Now, if I say go evaluate it, right, this says simplify. You have done. You don't have to do any more work. If I then go say evaluate, then you got to do 2 times 2 times 2 times 2, which is not that hard. And here, 9 times 9 is 81, and you can do that evaluation. Please know the difference between making things simpler and evaluating, finding the value. All right, so what would go on here? All right, so all these x's just disappear, right? 3 minus 3 is 0. They all go away. There's 0 x's left. Those 2 y's go, and 4 minus 2 is 2. So this is, well, that looks like a 9. Y squared over 1, which is y squared. You treat this just like x's and y's. The 2 cubed goes away. 4 minus 3 is 1. The 5 squared goes away. 3 minus 2 is 1. This is 2 to the first over 5 to the first. But you never, just like you never write 1x, you never write 2 to the first. You write 2. You never write 5 to the first. This simplifies to 2/5. So in this specific case, the simplifying and the evaluating answer are the same answer. Okay, because we don't write to the first. So let's practice this. Oops. All right, so 5 cubed times 5 cubed times 5 cubed is just 5 to the 9th. Don't start multiplying 5 times 5 times 5. All right, you just treat that like x. If you get confused, write it with x or y, right? And then you won't be confused. That would be x to the 9th. y times negative y to the first, right? That's 1 times negative 1, which is negative 1, but we don't write negative 1 in the answer. Y to the 5th times y to the 6th. This is negative y to the 6th. Negative times a negative is positive, so that'll go away. X cubed times x to the first is x to the 4th, right? This is multiplying, so we're adding the exponents. Y squared times y to the 5th is y to the 7th. This is x to the 4th times y to the 7th. Multiplying powers, add exponents. Y over y to the 6th, this 1y goes away, and you have 6 minus 5, 1, but this is 1 over y to the 5th. 17 to the 4th, 5 minus 4 is 1. This is 17 to the 1st over 1, which we would always write as 17. 7 squared goes away. 4 minus 2 is 2. 1/8 there, that goes away. 3 minus 1 is 2. This is 7 squared over 8 squared. You're done. You've made it simpler, right? That's the simplifying answer. If I then said evaluate it, then you would say it's 49 over 64, which is what it equals. So the 2 cubed goes away. 4 minus 3 is 1. 5 squared goes away. 3 minus 2 is 1. We have 2 to the first over 5 to the first. That's horrible. Exponents should be small, so this is 2/5. Good luck on the homework.